Okay, to start for the lecture thing on the next this topic we start. We talk about the residual analysis on the array analysis. Okay, for after you check the linear regression that on the square based on hypothesis case on the coefficient beta 0 and beta 1, and also you check the regression is okay or not, and you check the lack of it, is have lack of it or not, and then the overall you have to check the residual or you analyze the residual because all data that you analyze based on normal distribution. That's why you have to check the residual. Residual means area of your observed data. Oh, I forgot to check. Sorry. Okay, you observe data. Yes. The residual that we would like to check the error between the fitting error, fitting value, and the real data or observed data. That's right. For that case, we have about 4 techniques to check. The first, you check the equation is accuracy method for this case. You would like to check the normal cost of residual. Right. The residual, again, residual is the difference between observed data and the predict data. Predict data obtained from the equation. That's after you fit the data from y equal to ax plus b, y equal to beta 0 plus beta 1x. That's right. You read your data from x1, that's right, x1, y1 equal to this value, and then you substitute x1 into the fitting equation. That's right, you calculate error between the fitting and the observed data, you get residual. That's right, residual is value with x value also for that case. And then you plot residual with a normal plot. If it is normal plot, okay, you can conclude that the technique that we use to fit the limit is accuracy enough for that case. And also for the second one, we check by the average residual is 0 or not. That's why we have error. Again, error is it mean residual, the same limit, the residual or error. If you average your error is 0, okay, you can conclude that your technique is accuracy enough for that case. And another thing is which variance should be constant. Variance also error. Variance means standard deviation square. Standard deviation means the value that to check the deviation from the mean, or error from the mean. That means variance constant, average is 0. Plot of residual is normal, and the last one is your residual is no pattern. When you plot the residual and x value, right, there is pattern. No pattern means the residual is increase with x, decrease with x, something like this. This is the pattern. If there is no pattern, no increase, no decrease, it's scattered. Okay, it can conclude that your technique that your fit your equation is accuracy enough. That's right. This is the technique to confirm your data, your equation, your technique is accurate enough. So because this is based on the technique. Okay. And I talk to you for this, if we plot I mean the residual or error. That's right, residual error. This is, you can find that this is the scatter, no pattern, right? No pattern. Right? This is accurate. Like you plot the residual. And the data. And for this, it has some pattern, that's right. We have some pattern. This also we have some pattern. This is decrease and increase. Right? 3 of this is inaccuracy. Right? Inaccuracy. If you plot the residual, it look like 3 of this B, C, D, you can conclude your technique. That's why your fitting equation is not accuracy. That's why not accuracy. For this case, if we use the same data, but we have to fit the residual, you follow it, and then we have some activity that we have to go to the select and fit and residual plot. Right. You fit a residual plot. You see some residual, residual. And also we have what this. This is your normal cost of residual. This is residual. That's right. Residual is maybe negative or positive. That's right. Because we did not calculate the absolute. We calculate the error from observe and predict. It may be negative or positive. You put normal curve. This is approximately linear. Okay, you can put this is normal. And also this is the residual and fit value. Right. This residual and fit value. This is the residual and fit value. It's also scattered, no pattern. That's right. If look like previously, some pattern, right? Okay. This is some, there are some pattern. Right. It's also decrease, increase. It's also like this. This is inaccurate, but for this example, it's scattered, no pattern, no increase, no decrease. It's scattered for that case, and also the fluency for this. And this is some residual and observed order. Observed order means data point 1, point 2, point 3, we have about 20 data, okay, you got. And then we have the error is with negative, positive, input 0. That means it's scattered around 0. And no pattern also. Okay, we can compute your data, and like for this is accurate enough. That's right, accurate enough for this. And also is some residual. This is the observed. Like this is the predict residual, for example, for 20. Right. Put you can do by yourself. Very simple. You have to say, but you have only to add some. I will show you for the previous data. Okay. I have some data. Okay. Okay. We check this. We go to perspective. Regression and regression model. Yes. This is the response is y, corrected is x. We go to this, we have some fit and less local. Some option that graph. For this case, we will plot 4 in 1. 4 in 1 means we plot histogram of residual. Like normal plot we plot residual versus fish and residual versus order. Like for this case, the graph will plot look like I show you. We showed 4 of this. Like for this case, you click again for we go to graph. Right. This is if you will click only histogram, you show only histogram. You click this is normal, it's normal. And then I think you can click this, it's 4 in 1. That's right, 4 in 1 page. If you click this, it's separate graph. It's separate graph. It's up to you. But if you click this, it will plot flow graph in 1 page. Flow graph in 1 page. It shows you the curve in flow graph like that. This is the normal part of residual. This is also some residual. Right? This is the residual in fit value. Right? This is the fluency and residual. This is the residual and observed order. Right? For that. And then there is no pattern. Right? And also normal part. You can conclude your technique that you use to fit your equation is accurate now. That's like accurate now for this. Okay, this you can do that with. And if you would like plot separately, right, you can click the separate graph for that. Okay. And the next topic we will talk about the linearization. Linearization means you can transform from nonlinear to linear. That's right. I will talk about nonlinear for the last topic for this. But before that, I would like to show you how to transform from nonlinear to linear. That's right. This question is nonlinear. This equation is nonlinear, but you can transform this equation to linear. Right? But for this is y equal to beta 0 e over beta 1 x, and also some error. Right? This is nonlinear. If you would like to make it linear, you take log both sides. Yes, right? You take log both sides. You get log y equal to log beta 0. This is constant, that's right. This is constant, beta 1x, and log, and this is error, that's right. When you fit equation with it, this is also y equal to intercept, right? It may be beta 0 that, for example, plus beta 1x, right? This is linear equation, right? This is linear equation, okay, y that mean log 1, beta 0 that mean log beta 0. This is linear equation, right? You plot y that and x, right? You get slope of beta 1, you get intercept of beta 0 that. But y that is log 1, beta 0 that is log beta 0. This is the technique we call this is linearization. So you transform from nonlinear to linear. You can follow everything based on linear fitting. That's right. You can use linear fitting, but you for this case we call like you change the variable. Like you change the variable from log y into y, from beta 0 into beta 0 that. That's right. Log beta 0 constant, beta 0 that also constant. Right. And under this equation, like this is nonlinear based on 1 over x, nonlinear. This is nonlinear, so not linear. Right. But for this, you can consider linear. You change 1 over x is c variable. C variable. This is linear. Right. You get the equation. You plot y and c, but c is 1 over x. You plot it, you get linear equation. Right. And this is nonlinear. This is nonlinear. You take log both sides, and then you get this. You convert this from nonlinear to linear. Right. This is y. This is beta 0. This is beta 1. This is also linear. That's right. This is also linear based on y is 1 over y. For this case, it's equal to you rewrite this to this side, from this into this side, and this into this side, and then you take log both sides. You get linear. That's right. For that case. And everything is the same, linear regression, right? But only you change the variable from nonlinear to linear. Okay, for this example, we would like to investigate electricity that you made from windmill, wind turbine, windmill, yes, wind turbine, that's right. กังหันลม that's right, in เขาใหญ่เที่ยง. And we go to เขาใหญ่เที่ยง on this Sunday for Minitab. 72 kilometers. I visit every year for ลอยฟ้า marathon, but every year I do 10 kilometers. This is the first time in 22. ไปได้กับเขาใหญ่เที่ยงเสาร์อาทิตย์นี้ได้ because in เขาใหญ่เที่ยง slope is quite high นะมันสโลปค่อนข้างสูงมากเหนื่อยมากนะครับแต่ก็ได้วิววิ่งผ่านกังหันลม Okay, back to this part. Okay, for this case, we use the wind turbine or windmill. That's right. Windmill the wind will rotate turbine. That's right. Turbine will generate mechanical energy. Mechanical energy will produce electrical energy by generator. We have step by step. Right. And also, if we use the water turbine, we have some water at the top of our engine. Water turbine, the water will flow to rotate the turbine. That's right. Turbine will rotate kinetic or mechanical energy, and mechanical energy will transfer to electrical energy by generator. Check your permission in picture. You see the note like we have the wind turbine, wind from wind will rotate turbine or wind wheel. Water wheel or water turbine, water will rotate turbine. That's right. And turbine will generate electricity. But it's different pump. I think you know pump. Pump, you have to add energy, but turbine receive energy from wind, from water. But pump, you have to add energy. Pump will work. Okay, it's different. It's opposite. That's right. Because wind turbine generate energy. That's right. But pump is not generate energy. Lot energy. Right, for this case. Okay, for this case, we talk about the wind turbine. We produce the energy by wind turbine in DC output. DC is direct current. We have the data, it's verified data from this. This is corresponding the DC is related with the wind velocity. That is high velocity. It also it can generate the mechanical energy. That's right, mechanical energy. For this case, the DC is output correspond. It depends on wind velocity. That's right. It depends on velocity. Okay. This is in terms of meters per hour. That's right. Meters per hour. DC is output. That's right. Current X and Y. Okay. But for it, if you plot output and X or DC output and X, it's not linear. That's right. You plot Y and X. It's not linear. If you fit with linear, R square is very low value, it's about 0.87, right, for this. And you check the p value for this. This is not linear. For this case, we try to fit with non-linear side. This is we check the error. It's also some pattern. That's right. For this, if you fit with linear, then the error is they have some pattern, but not accuracy for this. Okay. And then that we apply non-linear. Previously we apply linear. That's right. We apply linear, and then we apply non-linear. We plot y and 1/x. You get linear, right? You get linear. You get linear because this is linear. So that is 1/x. You get linear for that case. This is the transformation. You can use this by this is x dash, right? X dash is also linear. That's right. Linear with respect to a new variable. A new variable is x dash, not x. That's right. X dash is 1/x. If you got a y and x is non-linear relationship, y and x dash is linear relationship. Okay. This is the technique to linearization. That's right. Because it's non-linear, it's difficult to fit or difficult to solve if you have no equation. That's right. Okay. This is the technique. You get this equation from non-linear like that, and increase r squared. And also this is p value after you check, and this is the MSE mean square error. It's quite low value for this. And then also you got the residual. It's not pattern. That's why from previously it's got the with linear. You get some pattern. This is increase and decrease. Right? This is not accurate. If you convert to this equation, okay, you check the R square, you check the residual, like this scatter, no pattern. And the normal part, that's right, this is or not normal part, this is also the normal property is close to linear, but not perfect, but it's close to linear, like this. This is the normal part. Right? Okay, this is the technique to linearization for this. I also have the Minitab, but this is a way to show you, but this case you have the data for this. Is that x that you have to plot y and x that not x, okay, y and x that or y and 1/x is linear. If you plot y and x, you not get non-linear for it, and then you do follow the same technique by linear regression. Linear regression. Get the equation for that. And also this is the normal part. This is the residual and fixed value, no pattern. That's right. And the residual and observed order is include 0. That's right. If the error or error is in the negative, in the positive side, or in the negative side only. That's not accuracy. That's right. The error should be negative and positive. That's right. Should be negative positive. That's okay for this. But sometimes you get the error is only positive, error is only negative. That's not correct for that. Okay, sorry, I forgot to I copy from my book in the bachelor degree in Thai. So it is translated. I use this by Excel. Right? Okay. For Excel, we have some optimization program. Right? In Excel, if we have the proceed or solver, right? Someone do this a lot. Right? I will show you some equation. Right? For this, we would like to fit linear equation. Right? In Excel, we have the linear, and then you pick 10 line. Also, you can get this. Right? And this is the solver can helpful when you got the nonlinear. If you cannot linearization from nonlinear to linear, for that case, you have to fit with nonlinear. I will talk to you in the next topic. But for this case, I will apply the solver for linear. Right? So for linear, we have X data like this. I'm not common okay, this is X, this is Y. Right? This is linear equation Y equal to C0, C1X. What is it? Y predict. Y predict. How to predict? We have to try out and look C1 and C0. Like for this, the solver and coding is made a trial and error technique. Program try to assume C0 and C1 and then calculate Y and then compare Y predict and Y observe until it's very low value or close to zero. And for this case, okay. For the first step, I assume C0 and C1 equal to 1, right? Equal to 1, then you substitute C1 and C0 into this equation, you try equation this. You get this is the Y predict, and then you calculate SE sum square or square error. Why we use square error? Because the square error you will get positive. That's right. Because if you use the error when you sum, this is sum square error. But the negative, positive will be cancelled. Because you error negative or positive is also error. That's right. And sum of error. Like for this. And then we can use the solver. Solver will optimize. This is the optimize technique. I will talk to you in this. The optimize technique. But the basic simple case is we program try to assume C0 and C1 and then substitute to Y and then calculate Y predict and Y observe. If the error is equal to 0, okay, we accept for that case. If not to 0, you have to change value of C0 and C1 again. That's why we trial and error. It's manual for about 20 years ago we use by trial and error. But now it's many programs can help you. Can help you. When I study bachelor degree, I have to try out and assume until you get the correct one. But today we have a lot of programs can help you. Okay, I will show you in Excel for this.ไม่ยอมทำงาน It doesn't work my com คลิกขวาก็ยังไม่ยอมหยุดผมจะมันเปิดไลน์โปรแกรมนิ่งเลย คือแล้ว Okay. Okay, for this case, right, is ท่าทางกับใคร Okay, for this, like we start from this is free C0 and C1 is constant. That's right. C0 and C1 is constant. Okay, but it's the first step. I assume C0 and C1 equal to 1. This is the first gate or initial gate. That's right. You have to input the initial gate. Okay, you can input any number. That's right. If you input the number that goes to the real answer, you get the answer quickly. You get the answer quickly. Right. And this is why this is observed data. Right. This YPD, how to calculate YPD? YPD equal to YPD. Okay, YPD equal to C0 not C1x. Right. C0 by C0. C0 is right. And then we have to fit C0 with B2, cell B2. We have to F4. $B, $2. This is you click F4 in computer. This means that C0 will fit at cell B2, right? Cell B2. Plus, plus C1 multiply F. Where is C1? This C1, right? And also the same, we have to fit C1 at cell B3. You click F4, right? If you don't like to click F4, you type $B, $3. Okay. Multiply x. This is x, right? Multiply x. This is x. Yeah. This is the YPD. If you substitute C01, C1, 1. Right. This is the error. We call it absolute error. Right. I observe value may not predict value. Predict value is C. Is it right? Okay. Is it square? Right. Okay. We get this. And then you're not necessary to type for all cells because I fit B2 and B3 already. You can collect for, right? You collect for. This is also it change only cell of X. The size cell of X. This is A. This is for A6, A7, A8, A9, A10, but B3 and B2 is fixed. The size. Okay, and then you calculate the error. This square error. Square error. B6 minus C6, B7 minus C7. Right, for this. This is error is very high. That means your first gate is not correct. Like we try to optimize that sum square error close to 0. Right. If the sum square close to 0, the assumed value is close to the real value like that. Okay, for this case. Yeah, and then you go to the solver. Right. I talked to you about that. Right. You go to data. Solver like this. My computer is can. Okay, this is you. Okay, you pick this the objective. Objective means we would like to optimize or set this value equal to 0. Right? Set this equal to 0. Okay, you collect this cell. This cell we need equal to 0. Right? The 11. Okay. We would like to maximize. If you would like to minimize, no, I would like to set value equal to 0. Right, or is 0 approximately. And by assume this, we have to change this value. You can select both of this. This is B2 and B3. And also you have some constraint or not. If you know why the 0, it should be between 0 and 1. You can add the constraint. If you know the constraint, you can add the constraint of C0 and C1. For this case, we have no constraint open for, we don't know like this. Right. And then you did the technique. You have the GRN nonlinear asymptotic linear programming. And we talked to this in the, it's maybe on the last week, a little bit for that. For you. Right. The option we can set up the tolerance or the minimum error that you accept. I ต้องได้รีบลองต้องได้เบรกอีกรอบ This is the tolerance of physics that is about 10 minus 6. And the iteration number, how many times that you would like to assume value of C0 and C1? Right. For the case, we should iteration is 100, 100, that's right, operation sign or iteration 100. แต่หยิบคลิกโซ่ยังไปมันที่จะทำแอนโอเคตอนนี้มาลองเทสโอเคเป็นพอลีสตาร์ทคุณเทสอีกรอบเป็นขอรีสตาร์ทเพิ่มว่า อีกสัก5 นาทีเราได้ความนี้แล้วกันนะครับนี่คือ5 นาทีตามกดได้เลย